Hello and welcome to the chapter about blending basics. In the previous chapters, blending was mentioned a lot in different positions of the manufacturing chain. Before I go into details about the process, let's discuss what blending is and how the blend quality is quantified. Let me begin with the definition of blending or mixing, as it can be called. Blending is the reduction of inhomogeneity in the substance. If two powders are mixed, the ideal homogeneity would be reached if any sample that is taken from anywhere in the blend contains exactly the same proportions of each substance, as shown here for a case of a 50-50 mixture. In practice, such an ideal mixture can never be reached in powder blends. Also, blending and segregation occur at the same time. Those are opposing effects that reach an optimum after which more mixing might decrease homogeneity. Therefore, we have to define what our process goal is, and we also have to define our sample size and sample taking procedure. We will explain more about sample taking procedures and options in the course about material properties. To define the process goal, we need to define the blend quality we want to reach. To do that, we need to understand the effect of sample size on the result. What you see here is a random mix of two substances with equal mass of red and white. It is not a perfect mix, but I already explained in powder mixing a perfect mix is impossible. So now how do we classify this blend? The relative standard deviation, or RSD, of taken samples is commonly used to quantify the blend quality. This is the definition of the RSD. You will find the equation with an explanation also after the video. In general, the smaller the RSD, the better the blend. Theoretically, we should take an infinite number of samples. This is not possible in reality. So what do? We need to define a sample size, and all samples from one blend should be the same size. And we often do not know the true overall concentration. Thus, the equation changes to this one, where we use the mean concentration and a limited number of samples instead. We call this empirical RSD, because we use S, the empirical variance, instead of sigma, the true variance, to calculate it. When someone refers to the RSD, it is often the empirical RSD. The sample size is crucial to the result as well. At first glance, this is not easy to grasp. So let me explain why that is. Here I depicted again the random blend example. At the first example, we choose the smallest possible sample size, just one block. In the second example, we choose a sample with 64 blocks, the largest possible sample. For the first example, we get an RSD of 1. This means that material is not mixed at all. The second example results in an RSD of 0, a perfect mix. This is not the reality, as you can see. The following two examples have a sample size of 4 and 16. There is quite a difference in the RSD result. The truth can be found somewhere in the middle. We can conclude that the ideal sample should be significantly smaller than the total and at the same time be significantly bigger than the smallest unit. In fact, sample sizes should be chosen to be similar to the mass of a dosage form. Also note that taking samples from a powder bulk at rest is very difficult and associated with many sources of error. These were the basics for blend classification. Thanks for your attention and see you soon for the next video.